All right, so worst teacher award goes to me. I am so sorry that I forgot to make your video, and it's probably going to be shaking the whole time because I'm doing it at home. All right, so write the rule of this sequence. So all of our rules always start with t sub n equals, and where does it start? It starts at 180. So we have to decide how it's changing, whether it's arithmetic or geometric. So it's either going to be y2 minus y1 that's the same, or y2 divided by y1 that's the same. So we could take 138 minus 180, which equals negative 42. 96 minus 138 is negative 42. So each time you're subtracting 42. So starting at this 180, minus 42 times n minus 1, because it's an arithmetic sequence. Here it's a geometric. So again, where does it start? T sub n starts at 45. And it's a ratio. Ratio means we're multiplying. So you're going to multiply by 3. And when you multiply, the little exponent is n minus 1. Okay, so you've got to ask yourself, why am I using n minus 1 rather than x? If it is a sequence, you're going to be using that n minus 1 because this is the first term, not the 0 term like we get with functions. So that's why you have to use that n minus 1. Okay, so for here, what is it asking us? I think it's asking us for the function rule. I'm sorry, I should copy that down. All right, so again, t sub n equals 4. Now I need to figure out how I'm getting there. So this could be plus 8, but that's plus 24, so it's definitely not arithmetic. So we're going to take y2 divided by 1, so 12 divided by 4, that's 3. 36 divided by 12, that's 3. So each time you're multiplying by 3 to the n minus 1. So that would be your function rule. Okay, number 4. We have to decide which one is true. So we got to look at them and decide whether it's true or false. So it begins at approximately 5. Halfway between 0 and 10, I'd say that's true. Here, decreasing by 5%. It's definitely not decreasing. That's false. Okay, increasing by 5%. If I was to write my equation, y equals, it starts at 5. To increase by 5%, anytime you have percents, you start with 1 plus, and 5% is 0.05 to the x. I could plug that in my calculator and see, is 3 equal to 10? Is 4 equal to approximately 18? This is false. It doesn't match. Doubles. So if it's at 5, at 1, it should be at 10. 2, it should be at 20. 3, it should be at 40. So that's not where it's at. So this is false as well. 5. Which one shows doubling? So looking at these, we have to see, like all these others, first comes the start times the rate to the x. So for doubling, this is a rate of 2. So which one has it starting at something times 2? Not that one. Starting at something, that's not times 2. I mean, that starts at 2. Starts at 2 times 100. Nope. Here, starts at 100 times 2 to the m. So D is your answer. Here it gave us a table. Again, I don't have my calculator with me. Thankfully, I did these several times. So to find the rate, we take y2 divided by y1, which is going to be 5150 divided by 5,000. So the rate is 1.03. So if I'm going to find f of 6, I first want the function to plug in my calculator. So y equals, where does it start? 5,000. The rate is 1.03 to the x. Okay, again, I'm going to ask you, why is it to the x when these were to the x minus 1? Because this is a function, not a sequence. So you can plug this in your calculator and then go to where x is 6 to find that value. I know I'm going kind of quick, but it's because I want to be able to upload the video. So just pause it if you need a chance to go back over one of these. So here, the population of 7,000 increases by 5% over the next 5 years. This is the domain. So what is the range? So again, first, let's find the function so we can fill in our values. So y equals, where does it start? 7,000. We've got a percent, so all percents start with 1, and it's increasing, so you're adding. And to change 5% to a decimal, it's 0.05 to the x. So then what is the range? You're going to list the values that match up with these x values. So when it's 0, it's at 7,000. When it's at 1, it's at something else. All the way to when it's at 5, it's at approximately whatever number it gives you. Okay? So you list out those values. Again, this is discrete, not continuous. You're listing out the values. You're not going to have half of a bunny. Because I think that's what it is. Population, so people. You're not going to have half of a person. All right, so write a situation to match this. So just like with all these other examples, this first number is the start. It's got a 1 here, so I'm guessing it's a percent. So this part is the percent. So it's 20%. And it's greater than 1, so it's an increase. So I'm going to say, Frank started with 200 fish. Why I chose fish, I don't know. And the population grew at a rate of 20%. All right, so here, population of 1,200 rabbits increases by 2.5%. Again, we've got a percent, so you know it's got to start with 1. So you can automatically eliminate C and D. It's increasing, so it's 1 plus, and that's your B. So for the domain, these are the X values. It wants to know at the end of 5 years, so 0 years, 1 year, 2 year, 3 years, 4 years, 5 years. And you're matching up whatever Y values go with that. So at 0 years, it's 1,200. I don't know what it is after that. Something, 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 something. 1, 2, 3, 4. And then at 5, it was 1,358. Ta-da! Okay, here. It gave us a graph, and we had to match it to the equation. Okay, looking at this graph, is it going down or is it going up? It's going down, so it's decay. So the rate has to be less than 1. So that gets rid of A, that gets rid of C, it has to be B. When it's asking me domain of an exponential function, they're all the same. It is always all real numbers for the domain. Sorry, I went crazy there with my camera. The range is always Y is greater than 0. Because what do we have right here at this line? Something it never touches. Can't touch this. Dun, 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 dun. Y equals 0 is your asymptote. It is never going to touch that line. Now it's important to remember that we can also call that line the x-axis. Okay? Dude, we're flying. All right, here. Which of these is not true? Very important to look at that not. So the initial was 50. Okay, that's true. Increased by 100 every hour. So at 1, it was, okay, so at the beginning it was at 50. At 1, it was like at 100. It's at 200. 3, it's at 400. So that's false. Okay, well, that's your answer right there, but let's just keep going. Doubled every hour. 50, 100, 200, 400, 800. Yeah, it's doubling, so that's true. At 6 hours, it would be at 3,200. Well, at 5 hours, it's at 1,600. And if it's doubling, then yes, that would be 3,200. Okay, circle which equal 4. Do you see any variables? Any x's, any y's, any a's, b's, or c's? No, which means you can plug these in your calculator. 8 caret, write this out, 8 caret parentheses 1 divided by 2. Make sure you put that in parentheses. It's going to get you a nasty decimal. This does not equal 4 because it's also the square root of 8. Okay? Here, when you multiply, you add the exponents. So that'd be 2 to the 4 halves, which is 2 squared. 2 times 2 is 4. So 2 does 2, the bottom number is the root. You think of your trees, remember? On the bottom is the root. So it's the square root of 16 to the first power. The square root of 16 is 4. 3 is. And remember, you can just plug those in your calculator. Same for 13. You'd have 6 caret parentheses 7 divided by 2 times 6 caret parentheses 1 divided by 2. This would end up giving you, it's like 12 something. I really wish I had my phone with me, or my calculator, so I could calculate the exact number. But it's like a big number. It's not 216, so it's 216 times 6. So 36, 6, 9, 1296. Old school math. Woohoo! Okay, so circle all that are equivalent to the square root of 48. Again, you could just type that in your calculator. There's no variables. It equals 6.9 approximately. And I could type each of these in my calculator. This equals 6.9. Yay! This equals 6.9. Yay! 6.9. Yay! 6.9. Yay. So let's talk about why they're all equal. Remember back to jailbreak, because that was my favorite lesson, so I know that you did. We want to break it down into our twins. 48 can break into 16 and 3. Hey, looky there, 16 and 3. There's C. 16 can break into 4 and 4. Hey, so that's 3, 4, and 4. That's D. Do you remember your twins? There's some twins. One gets shot, one gets out. The 3's left in jail. There's your A. 4 breaks into 2 and 2, 2 and 2. So there's your 2, 2, 2, 2, 3. There's your E. Fantastic. 15, which is not equal to. Again, it's not equal to. Guys, what is 4 divided by 2? 2. So which one is not equal to 5 squared? 5 squared is 25, so this one is. Okay, the bottom number, remember, think of your tree. Bottom number is the root, so it's a square root. This has a 4th root. This is backwards. This one is not equal to. False. Okay, here's square root of 5 to the 4th. And 5 to the 4th, 5 times 5 times 5 times 5. 5 times 5 is 25. 25 times 25 is 625. So this is true. So remember, roots are on bottom, powers on top. Okay, last page. These are your exponent rules. Okay, I'm going to go ahead and stop and then send this one out separately because my time's getting long.